Directional bonding video part 2. So this video is all about the formation of H2 molecule and potential energy curve. So the formation of H2 molecule and potential energy curve. So on the x-axis there is an internuclear distance and on y-axis there is a potential energy. Initially, the two hydrogen atoms are away from each other, as you can see here, right? So initially there is no overlapping and no attraction, and hence their initial potential energy is considered as 0. As these two hydrogen atoms come closer, there will be some overlapping and some attraction, and formation of H2 molecule will take place at the lower potential energy. As these hydrogen atoms start coming closer, so the potential energy also decreases. It is about formation of H2 molecule. When these two hydrogen atoms are far, their energy is set as 0 because they have not combined it. When these two hydrogen atoms come closer, their energy decreases because of formation of molecule, and lower the energy, stable will be the molecule. So this is internuclear distance for molecules forming through van der Waals forces. So the distance becomes the radius of atom. Molecule formation energy is low. That is why the molecule form a stable one. If energy would be higher, then the molecule would be unstable. So the H2 molecule which is forming here have a lower energy, and hence this H2 molecule is more stable. This energy becomes low because electrons of one atom now get attracted towards other nucleus of the atom. Next is wave mechanical treatment of hydrogen molecule on the basis of valence bond theory. There are two isolated hydrogen atoms which may be described by the wave functions psi A and psi B. Now psi A is stand for the wave function for hydrogen atom A, and psi B is the wave function which stands for the hydrogen atom B, and these both hydrogen atoms are isolated. If the atoms are quite far apart, they do not interact, and the system can be represented as shown in equation 1. Psi is equal to psi A1 and psi B2. So this is the equation 1 for the atoms which are far apart, which are not interacting. Where 1 is the electron of atom A and 2 is the electron of atom B. When the atoms are brought together to form a molecule, they will affect each other and their individual functions will change. However, when they come closer and interact, the wave functions for the system will also change. But still we may accept the equation 1 for the new system and then try to improve on it. So there are 3 improvements for these equations. Improvements suggested in equation 1, that is psi is equal to psi A1 and psi B2. First improvement, exchange energy. Second improvement, its shielding effect. And third improvement, ionicity. Now let's start with the first improvement, exchange energy. First improvement was suggested by Hitler and London. Electrons are similar, they are indistinguishable. We cannot distinguish the electrons from each other. Hence, electron cannot be labeled as 1 and 2. Hence, equation 1 has to be changed. So, the equation 1 now will become equation 2. Psi is equal to psi A1 and psi B2 plus psi A2 into psi B1. So the electrons are similar and they are indistinguishable, right? So we cannot label as electron 1 and 2. Hence the equation 1 will change to equation 2. Increase in bonding energy is called as exchange energy and the molecule is stable. Now the shielding effect. As you can see, there are outer electrons and inner electrons. This is outer orbital and this is inner orbital. So the electrons which are present in inner orbital and outer orbital will repel each other. The shielding effect can be defined as a reduction in the effective nuclear charge on the electron cloud. So there will be decrease in the nuclear charge and this is called as the shielding effect. Second improvement, that is about the shielding effect. Electrons have the capacity of shielding one another so that the effective nuclear charge Z star is generally less than the actual nuclear charge Z. The electron of one hydrogen atom shields the electron of other hydrogen atom from the nuclear attraction of its own atom. The wave functions of A and B need further changes. And that changes are the value for this curve 3.65 into 10 raised to 2 kilojoule mole inverse forward bond energy and 7.43 into 10 raised to minus 2 nanometer for bond length. And the third improvement is ionicity. Two hydrogen atoms get combined to form a ionic bond. So in first case, the first hydrogen atom will have positive charge and second hydrogen atom will have negative charge. And here the first hydrogen atom have negative charge and the second hydrogen atom have positive charge. So this is ionic bond. Electrons have been allowed to exchange place in equation 2. It is assumed that the exchange places simultaneously so that if electron 1 is associated with atom B, the other electron has also gone over to A. If two electrons were with one atom, it would acquire a negative charge and other hydrogen atom would acquire a positive charge. Suppose there are two hydrogen atoms and one hydrogen atom have two electrons, right? So that hydrogen atom will have a negative charge and the other hydrogen atom would have positive charge. So the equation 2 will get modified as follow. Psi is equal to psi A1 psi B2 plus psi A2 into psi B1 plus lambda psi A1 psi A2 plus lambda psi B1 into psi B2. So lambda is the mixing coefficient. Equation can be reduced to the following form. Psi is equal to psi H2 plus lambda psi of H plus H minus plus lambda into psi H minus H plus. So this is the equation 4. Where this first term is for the covalent character and the second term is for ionic character.